Welcome, my name is Chris and this is the third video of our DOCKTITE YouTube channel. This time I will show you how to dock a covalently bound ligand when you don't have a template ligand in place. So we have to create dummy atoms this time. I used just the same example as in the last video. For all ligand preparation and receptor preparation steps, please see the last video. This was post-prediction of PDB ID 1INC. We had a benzoxycenone warhead-bearing ligand in this example and docked it into the pancreatic allostase. Okay, I use the files from the last time, the COFREC prep MOE, and you see we have no ligand in place. But we have our serine residue here. We know this serine residue might be the nucleophilic residue for our docking, and we want to assign the active site around it. For this purpose, we go on Compute and open the Site Finder application. We can just use the default values and click on OK. On Apply, excuse me. We see the first site is just around the serine residue. This looks very nice. The second one is far away, we can skip this. And the third one is again around the serine residue, now on the other side of the serine residue. As we don't know exactly where our ligand will be docked, we use just both of the sides. We have now a very nice surrounding of our serine residue. And we create dummy atoms by clicking on dummies. Now MOE asks if we want to create dummy atoms at the alpha sphere centers here. We want to do this. Now we can close the Site Finder application and we have our dummy atoms in place. So now we have to delete the nucleophilic residue for the docking purpose and the surrounding, the neighboring atoms. I just showed you this in the last video, but we will do it here again. Now we have the problem, it is not violet, right? But when it is per default active, but if it's not active, you can go to select and synchronize. Now you have everything that is selected in the MOE window also selected in the sequence editor. Now I selected the serine here, and now I see this serine is the nucleophilic one, even if it's not with the violet margin. Now I select the surrounding amino acids and I show the selected. I delete nucleophilic residue and I delete carbonyl group and amine group of the surrounding amino acids. I will just save this file as a new file. It's now our 1INC ser del MOE for this example. And I save it as a MOE file. The next steps are just as in the last example. We go on pharmacophore docking. Oh, but we have to change the force field before. We can change the force field by clicking on this button here. Now the Merck molecular force field, what's the default, is selected. We click on it. We load the MB12 force field and fix the charges. Now we see we have selected the MB12 force field, which is now used for everything we make, like energy minimization or docking refinement. Okay, we use the default output name. We use our pharmacophore file, just the automatic one like in the last example. But now you see, before we used as the site definition ligand atoms. We can't use this one because the set contains no atoms. but we created dummy atoms, we can now use site dummy atoms. As ligand, we use the attached ligands like before. We use pharmacophore docking, raise the number of returned poses to 5000. We use the affinity DG scoring function. We retain 100 poses. We use force field refinement, retain also 100 poses, and now we have to set the force constant for the force field refinement by clicking on configure and set the force constant to 1 to the power of 9, just like in this last example. We are done now. We can click on run. And we can watch what MOE is doing now by clicking on the SVL button. So now we have 7,101 hits from pharmacophore search, like in the last example. We return 5,000 of them and keep 4,000 non-duplicate poses, and we refine 100 poses of them. As this is just the same as in the last example, it makes no difference if we define the site by ligand atoms or by dummy atoms. I will skip this now, and I recommend to watch the last video for the further steps like RMSD calculation and sidechain cleavage. Thank you very much for watching. I hope this tutorial helped you, and now you are able to dock without a template ligand in place. I hope we see us in the next video. Thank you very much. Bye.